we are going to explain about a project titled Detecting Spam Email with Machine Learning Optimized with Bio-Inspired Metaheuristic Algorithms. So now coming to the introduction part, this approach promises to mitigate false positives and negatives, ultimately providing users with a safer and more streamlined email experience, bolstering cybersecurity in an increasingly digital world. In recent years, the integration of bio-inspired metaheuristic algorithms with machine learning has emerged as a compelling avenue for improving spam detection systems. These algorithms draw inspiration from natural processes observed in biological systems such as genetic evolution, animal swarming behavior, and natural selection. By applying these principles to optimization and problem solving, bio-inspired metaheuristic algorithms demonstrate exceptional adaptability and robustness in navigating complex search spaces, making them ideal candidates for enhancing spam detection accuracy. The objective of this research is to develop a novel approach that optimizes machine learning models using bio-inspired metaheuristic algorithms to create a more efficient and resilient spam detection system. By combining the strengths of machine learning with the adaptability of bio-inspired algorithms, the aim is to create a solution capable of detecting both known and emerging spam patterns with increased precision. So our main objective of detecting spam emails with machine learning optimized by bio-inspired metaheuristic algorithms is to create a robust, adaptive, and efficient spam detection system that can effectively combat the constantly evolving and sophisticated nature of spam, ultimately providing users with a safer and more secure email environment. Traditional machine learning algorithms may require large amounts of labeled training datasets and extensive computational resources, which can be time-consuming and costly. The use of bio-inspired algorithms can help optimize the learning process and accelerate convergence to optimal solutions, thereby reducing resource requirements and computational overhead. By integrating bio-inspired metaheuristic algorithms, the detection system can better handle the dynamic nature of spam campaigns, as they can quickly adapt to spamming techniques and patterns that may emerge over time. This adaptability allows the system to maintain high accuracy rates and reduce false positives, thus providing users with a more reliable and seamless email experience. So now coming to the requirements, we have two types of requirements, that are hardware requirements and software requirements. In hardware requirements, first, operating system as Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirement part, Python IDEL, that is 3.7 version is required. So now coming to the methodology part, first, upload spam dataset. The first step in the process is to gather and upload the spam dataset. This dataset comprises a collection of labeled emails where each email is categorized as either spam or legitimate, that is non-spam. The dataset should be large enough to provide sufficient examples for training and evaluation purposes. Second, pre-processed dataset. Before using the dataset for training the machine learning models, it needs to be pre-processed. This step involves cleaning and transforming the raw text into a format suitable for analysis. Common pre-processing steps include converting all text to lowercase, removing special characters and punctuation, and handling any missing or irrelevant data. Additionally, dataset may be split into training and testing sets to evaluate the model's performance accurately. Third, run TF-IDF features generation. To extract meaningful features from the pre-processed text data, the term frequency inverse document frequency, that is TF-IDF, method is employed. The TF-IDF calculates a numerical representation for each word in the dataset based on its frequency in a particular email, that is term frequency, and its rarity across all emails, that is inverse document frequency. This approach helps to identify important words that distinguish spam from non-spam emails. Fourth, machine learning algorithms from PSO. With the TF-IDF features generated, the next step involves implementing machine learning algorithms enhanced by particle swarm optimization, that is PSO. PSO is a bio-inspired metaheuristic algorithm that optimizes the parameters of the machine learning models. The PSO algorithm simulates the movement of particles in a multi-dimensional space to find the best combination of parameters that maximize the model's performance. It ensures that the machine learning model is fine-tuned and adapted to the specific characters of the dataset. Fifth, machine learning algorithms with BAT. In addition to PSO, the dataset is also subjected to machine learning algorithms optimized with BAT algorithm, that is BAT. The BAT algorithm draws inspiration from the echolocation behavior of bats, where they use sound waves to search for prey. This algorithm further enhances the model's performance by exploring alternative optimization paths, helping the model converge to better solutions and avoiding potential local optima. 6. Comparison graph. After training both the machine learning algorithms optimized with PSO and BAT, a comparison graph is generated to evaluate their respective performances. The graph illustrates relevant matrices such as accuracy, precision, recall, F1 score, and area under the ROC curve for each model. This visual comparison allows researchers to identify which algorithm, PSO or BAT, offers the best performance in detecting spam emails based on the specific dataset used in the experiment. So now coming to the execution part. To execute the project, first we need to open the code folder. So now here we have a folder that is PyCatch, and in this we have two Python files which are containing the Python script in it. And here we have a folder that is named as that dataset. In this we have a dataset with the .csv file. Here BAT, function HO and main. These all are the Python files which are containing the Python script in it. And here this is the main Python file of it. This is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now to run the project, double click on run.bat file to execute the project. Here this is the graphical user interface. With this we are interacting with the program. Now click on upload spam dataset button to upload the dataset. Here I am selecting spam dataset and now click on open button to load the dataset. Here we can see that the dataset is loaded and displaying few values from dataset, and this dataset has two columns, where first column contains message label as a spam or ham and second column contains email message. Now click on pre-process dataset button to clean dataset. So here we can see that from each message special symbols and stop words are removed, and after equal symbols we can see message label. Now click on Run TF-IDF Features Generation button to convert message into TF-IDF count vector. Here we can see first column contains words from messages and remaining rows contains counts of that word. If word available, then that row will have count of word, else 0 will be put. I am displaying few vector values in over here. Now click on Machine Learning Algorithms with PSO button to train ML with PSO optimized features. So here, so now in first line we can see dataset contains 500 features, and after applying PSO features has been reduced or optimized to 304, and then train each algorithm with optimized features, and almost all algorithms got more than 95% classification accuracy on test data. We can see dataset contains more than 5,500 records, and for training application using 4,457, and for testing classifier accuracy application using 115 records. Instead of confusion matrix, I calculated precision recall and FS score. Now click on Machine Learning Algorithms with BAT button to train ML with BAT optimized features. So now here we can see dataset contains total 500 features, and BAT algorithm selected 246 important attributes, and then train all machine learning with 308 optimized features, and then for each ML we got 99% classification accuracy. And now click on comparison graph button to get the graph. Here x-axis represents algorithm names with PSO and BAT, and y-axis represents accuracy, precision, recall and F-score. All algorithms gave better accuracy with BAT features. So now closing this graph. So now coming back to the conclusion part. In the long run, as the collaboration between machine learning and bio-inspired meta-heuristic algorithms continues to evolve, the detection of spam emails will likely become even more sophisticated and resilient against new spamming techniques. Users can get benefit from improved email security and peace of mind, knowing that their communication channels are better protected from the pervasive threat of spam. Overall, this interdisciplinary approach brings us closer to a future where spam emails are efficiently identified and relegated to obscurity, fostering a safer and more efficient digital communication environment for everyone. Moreover, the utilization of these algorithms optimizes the learning process, reducing the need for extensive labeled training data and computational resources. This efficiency not only speeds up the detection process but also makes it more accessible and cost-effective for implementation on various platforms and devices.
For updates on latest project videos, please visit True Project's YouTube channel and subscribe.